in this question, we are going to take a look at finding velocity and position from acceleration and initial conditions. So first, we're going to look at acceleration, and that one is, I will write using components, 6t e to the power t e to the power negative t. And then at the end, I'll just add ijk in there. Okay, so I know that initial condition of velocity at 0 should just give me 0, 0, 7, okay, because it's just 7k. So to find velocity, I will integrate. Integrating 6t gives me 3t squared. Integrating e to the power t is the same, whether it's integral or derivative. Integral of e to the negative t is actually negative e to the negative t, okay? So that would have been final answer, but whenever you integrate, you have to add a constant of integrations, and this time it's a vector, c1. And so in order to find c1, what you need to do is plug in 0 for t. That'll give you 0, 1, negative 1. And then you want to add that to vector c1, and you should get 0, 0, 7. To solve for c1, we're going to subtract the vectors. So 0, 0, 7. I'm going to subtract 0, 1, negative 1. That would give me 0, negative 1, and then 8. Okay, so final answer for velocity, I am just adding that vector to my 3t squared. So 3t squared will stay e to the power t minus 1, and then minus e to the power negative t plus 8. So that's the final answer for velocity. By the way, to check your answer, you want to plug in t equals 0 in here and see if you get 0, 0, and then positive 7, which I do because e to the power 0 is 1, remember? So it looks like that works. So here I will just enter 3t squared and then I plus e to the power t minus 1 j. And then let me actually put that plus here, but then put this in parentheses. Okay, so that's that for velocity. Now, if I want to find the position, I need to integrate one more time. So let's integrate one more time. So this would be the position. So for the integral of 3t squared, that's t cubed. E to the power t is the same, e to the power t. Integral of 1 is t. Here, when I integrate negative e to the negative t, another negative comes in the front, and it'll cancel with the negative here. So that will become e to the negative t plus 8t. Now, again, we do not know this other constant vector. In order to solve for it, we need to use the initial condition. Now, they told us that r of 0 should be j plus k. So let's use that. So we have the initial condition r of 0 is j plus k, which is just means 0, 1, 1, right? That's the initial condition. Okay, so let's plug in 0 for t. We will get 0. Then e to the power 0 is 1. And then we'll get e to the power negative 0 is also 1. So that's 1. Plus this constant vector c2 should be equal to the initial condition, which was 0, 1, 1. So to solve for that, vector c2 will just be the difference between these two vectors. And guess what? Everything here is cancels out. So looks like vector c2 is just a 0 vector. So that means that this right here is going to be my answer. Let me just put that in there. So t cubed I plus e to the power t minus tj plus, and I've got this other one, e to the power negative t plus a tk.